Hi, so this is my third video about dependency injection, and this time I'm gonna explain with some examples the VContainer framework. I've used the VContainer framework in my Cosmos project, and now I'm just refreshing this with a sample project that I've just created. The link will be in the comment below. So this is not any tutorial video, it's just what I learned, sharing all. So the main thing is a lifetime scope. That's the parent and that's the head of this framework. So a class that will inherit from lifetime scope can have this method configure, which has a parameter of iContainer builder. So this will be the hub where all the dependencies will be registered. Now, lifetime scope itself is a mono behavior, so we can attach it in the inspector. So here what I have done is created application controller that inherit lifetime scope, and then I took references of 3 monobehavior classes. Then I've registered them as component. Now registering is, there are different ways to register. So you can see we can register a plain C# class. We can register using delegate factory all. So for now we are just registering using monobehavior. Exactly, this is what I have done. Okay, lifetime scope serialized field. So this is lifetime scope serialized field, and I'm registering as a component. So this thing will be registered in the DI container, and then we will see how we can use it. But anyway, this is it. There are a new way of registering. If it's in hierarchy, we can also do that, and can do it in a new prefab, do it in a new game object, can do it in the hierarchy with some new interfaces. Okay, under transform, and we can also call that when destroy and load instantly after registering. When I started it, it felt really a lot, but now after watching it for and doing it in my projects, it's really now very clear and very easy actually. Yeah, see, and this is how we can group all these components, all these registrations in just few lines. So I've done this a simple one, register as component, and then class 1 is a plain C# class. You can see. So how to register as plain C# class? To register it, what we need to do is we will call the register method, give the type, then we will define the scope, whether we want to register as a singleton or not. We can see plain C# class here. So we say we can also register C# classes as interfaces. This is how we can register them. So later we don't need to get service A as a type, we can get I service A or I input port. This method will work in replace of this same thing. Here we have to mention all the interfaces, but if we just call this, it will just get automatically all the interfaces that that class inherits or implements. Now there is an entry point. So if we register a class as an entry point, then if we have this marker interfaces, then that class will run the methods of these interfaces automatically. We'll see what it is. Here I have class 2. Now we have these marker interfaces. Let's see. One second. No, not this. Here. So first the monobehavior is direct call, then enable, then initialize is called. So this method will be called after these two have been called. And this is VContainer's own initialize method. This is how the start method will be called. When before monobehavior starts, this iStartup will start will be called. After monobehavior start, this post start will be called. This just gives an extra um, extension, more better way of handling sequence. Okay, so my application controller is registering class 1 as singleton, class 2 as singleton. So when it's registering this, it will be registered as singleton. And now it's also registering class 2 as an entry point. Okay, when it will register as entry point, then these methods will be called respectively at their own time. So first configure will be called before anything, even monobehavior awake. And here we will do all the registrations. Then in start method, we are injecting monobehavior 3. Let's see what is monobehavior 3. So when we do this injection, then container will search for monobehavior 3 script, will check for this inject attribute, and wherever it will find it, it will just run that method, and it will automatically provide the required parameter dependencies, and we can save them. So this is called injection. This is called registration. This is called injection, and we have another thing called resolve. Registration is register the classes instance, or the register the class as singleton or as an interface, whatever. Resolve is get the instance of the class if, as it's already registered, and inject is provide dependencies if the class provide dependencies to a class that it needs. So these are three main things: register, resolve, and inject. So here we can see that I'm injecting the monobehavior 3, so that means these will be called and it will be provided. So container will provide the dependencies automatically. And what this line is doing is I'm just telling, okay, I need a dependency of class 1, so I'm telling container.resolve class 1. So I will get it. Now, when did I register class 1? Here I have registered it. And now I'm calling class 1's inject dependency. Now why am I not saying, okay, container.inject class 1? This is because if I will say container.inject class 1, and if I provide an inject keyword like this, I can surely do this, but then there will be a thing called circular dependency. So if we see, we will see that monobehavior 1 already have a dependency of monobehavior 2. Monobehavior 2 has dependency of class 1. So basically monobehavior 1 have dependency of class 1. And now if we again want class 1 have the dependency of monobehavior 1, so it's just becoming a circular dependency. Class A is having reference of class B, class B is again having reference of class A. This is not a good practice. Circular dependency should not be used very often. It's very bad. So in my last dependency framework lightweight that I made for that Rangers project, it must be in, I will put the link. In that one I have made a dependency injection framework with post registration injection. What is post registration injection is, first I will register everything, and then later I will do the injection and resolves. So then I can have circular dependencies, because I am first registering an instance of class A, then registering an instance of class B, and then while after every registration is done, now I am searching, is there any dependency needed in class A? Yeah, if it needs class B's dependency, then just give it. Same goes for class B. But there are some problems. There is a problem, these. Okay, so it's not a good practice. Immediate dependency resolution is the best practice. Pause the video and read about it. It's really well mentioned. Okay, so if we need circular dependency, we better use it with the mediator. So service A, service B, and then we call service C or something, and then service A will be registered to service C, service B will be registered to service C, and service C will have both registrations of service A and B. That way is better. yeah, I would like to also show three things. So this is what register is, okay? And this is what resolve. This is what inject is, okay? So here we can see that in class 2 I didn't use the inject attribute, but now let's try spawning a player. So I have a player prefab, and in my mono behavior 3 I have this prefabs reference, and now in mono behavior 3 I'm spawning the player. So when I'm spawning, I'm not using the object.instantiate, rather we can see I'm using object resolver.instantiate. Why did I get the object resolver? We can see that through an injection we are storing reference of a iObject resolver. Then we are using it to instantiate. I can show you the here. If we see container API, so first we get iObject resolver's reference, and this is how we can resolve. This is how we can inject. So we can inject game object, and if we need to instantiate prefab, we can do this. Very simple. So I have done it, and then inside player I have to inject properties. So just when I will spawn, this will automatically do the injections for me. So after spawning, I'm running the player, and when I will run, we'll see that mono behavior 3 is available. Yeah, we can play and we can see. Spawning player, and then mono behavior 3 called player run, then mono behavior 3 called player, then mono behavior 3 log call. So this is what happening from mono behavior 3. We run the player, first we spawn the player, then we run the player, and then inside player we are logging. Yeah. After the start is done, then the post start is called of class 2. We can see that in here. That's it. There are few other things that we can do is how to use it in the factory patterns. These are very simple. The basic thing is just register, resolve, and inject. And then rest is you can do the same with scriptable objects. Register instance, do work. This is link. And yeah, thanks for watching.